All right, everybody, please help me introduce our two speakers, Ezra Woods and Mike Manrod, to discuss EDR visibility and evasion. All right, guys, thank you.
All right. Welcome, thank you. And actually, we walk around a lot, so I'm gonna go ahead and use this one. There we go. I'll try not to drop it this time. So welcome, like we've got something really that we're really excited about, a fun topic that we're gonna get into, but first, who are we? I'm Mike Manrod, AKA Crude Solutions out of Grand Canyon Education, lead the security team there, and also teach the CYB 320 malware analysis class.
Yeah, and then for those who don't know me, I'm Ezra Woods. I also work for GC as a security engineer, and then I also help out with a few other things Mike runs.
Cool. So, you know, how it all started, like this has been a fun journey. About a year and a half ago, Ezra was analyzing a sample of DarkGate malware, and you know, pinged me and was like, "Do you know what bypass it is?" And I'm like, "Gosh, it sounds kind of," or what AutoIT is. I'm like, "Gosh, it sounds kind of familiar." And we gave a talk here last year of both analyzing DarkGate and talking about that research, and a little demo of the fact that that AutoIT could be evasive. And then at Demo Labs, we released Bypass It, kind of an end-to-end testing framework with AutoIT. Well, a week or two after the CactusCon last year, when we talked about this, DarkGate switched to using AutoHotkey. So we were like, that's interesting. We should be exploring AutoHotkey as well. So along with some friends and colleagues, several people here, and actually, could you tab up to the acknowledgements? You know, obviously all the people we have listed here and more, several of you in this room contributed modules and functionality to bypass it. Most of those modules have been ported over to AutoPwnKey, the framework we're introducing today, so special thanks on that.
Cool. So for anyone who isn't aware, I just want to go over what AutoHotkey actually is. So similar to AutoIT, if you've heard of that, it's a legacy scripting and automation framework built for Windows. It's mainly used for stuff like personal productivity, so making hotkeys for inserting like date and time into spreadsheets, stuff like that. It includes the ability to install a script interpreter, so that'll be an executable that can run the scripts you make with it, as well as the ability to compile the scripts into a standalone executable. Like AutoIT, it also has a valid certificate, so a lot of things just inherently trust it, which makes it naturally evasive, because anything you're going to do maliciously with it also looks like the things people do with it non-maliciously. So it does have valid use cases, but in enterprise, it's not really very common. So it's most famous if you've ever seen like the articles about mouse jigglers. If you Google like how to make a mouse jiggler, AutoHotkey Reddit thread will pop up first for context.
So talking about AV, antivirus and EDR detection, I'm assuming like everybody here who's working on the corporate side in cybersecurity uses an EDR. And something I've been concerned about for a long time is the over-reliance on EDRs, right? Like if you asked me at one time, how common is EDR, antivirus evasion, I would have given you like an estimate, and my estimate would have most certainly been wrong, right? So I think, you know, one of the core things we want to take away from this, our goal with this project is mostly to retire this project, right? Like we want this to stop working. But what we noticed with Bypass It is it took a very long time to move the needle on that before things started detecting it. And the AV and EDR community are getting better now, but parts of it are still quite evasive even today. So for AutoPwnKey, Ezra put a lot of work into the UI, and you'll see that, making it practical and useful for pen testers, because we figure if red teamers actually use this because it's one of the most convenient and easy ways to carry out an engagement, then it's going to drive change faster because people will open tickets with their vendors and get this detected. But we've found a lot of this to be quite evasive, disturbingly so.
Yeah, and so before we actually get into the framework itself, I just want to do like a general overview of EDR products and why that relates to AutoHotkey being so evasive. So when it comes to most EDR products, they're going to be detecting in a few ways. It's going to be API hooking, so modifying DLLs to intercept API calls. Heuristic analysis, so looking at behavioral patterns of processes over time. And then also just event correlation, so aggregating and correlating data across different endpoints to detect specific patterns. How that relates to AutoHotkey specifically is, well, like I said earlier, heuristically, it's a legitimate scripting platform. So it's used for a lot of legitimate reasons, and those reasons are going to match what you're going to do maliciously with it, such as updating a registry key. That's a really normal thing to do if you're automating something like a deployment, but it can also be used maliciously. And then for event correlation, same thing. Its legitimate use case makes it hard to distinguish from malicious and benign activity if you don't actually know what's going on under the hood. Beyond that, like I mentioned, all of the binaries you make with it will be signed with valid certificates. It'll operate just like any other automation tool, and it can be installed at the user level and also has a portable interpreter. So you don't actually have to install AutoHotkey to run an AutoHotkey script. There's a valid signed binary you can download that can run any of the scripts portably. And then getting further into some of the things we'll go over, I just wanted to give an overview of DLL imports and process memory. So we're going to get into how the API unhooking actually occurs. DLLs in general, if you're not aware, provide reusable code across different processes for Windows. So when you start a process, it's going to import a bunch of DLLs that allow it to interact with the system. The import address table is where those are actually imported. So all of the DLL addresses will be listed in that table when a process is created. And when that happens, the PE headers for the process will contain the information about the DLL it needs. So essentially, you launch a process, Windows is going to read that PE header, give it the imports it needs, and it'll store those in the address table. And that's mostly for static imports. You can also do dynamic loading, which if you've ever done any malware analysis, you'll probably recognize load library and get proc address. Those are how you dynamically resolve those DLLs. So going back to EDR API hooks themselves, API calls are specifically the gateway between processes and the Windows operating system. So anything you want to do, if you're like creating a file, that's going to call an API. ntdll specifically contains a lot of the lower level API calls like writing files, reading files, deleting files, and many others. EDR products, to monitor that, when a process imports ntdll, it will modify each function in that DLL to add a jump to it, so that when a function is called, it'll send information to the sensor or agent or whatever you have running. So hooked functions allow EDRs to analyze, block, or permit the calls that you make to them after they place those jumps in there.
So ntdll unhooking restores the original system calls by removing the EDR modifications. So simply put, it just basically takes what the DLL is supposed to be if you didn't hook into it with your EDR product, and it restores the one running to what the original state would have been. Thus, the hooks are no longer there. So the direct result is direct calls without visibility or monitoring for the EDR. I think I was drinking when I put hopefully. You end up with this weird perspectival shift when you're working on things like this, because really the answer is unhopefully is what we should put there. But in this case, I won't steal Ezra's thunder. But
Right.
Oh yeah, so new features for bypass it, new features and updates for bypass it include ntdll unhooking, LSASS dumping, UAC bypass, thanks to Matt Handy, who actually attended our talk at Demo Labs, and thanks to Russ for giving us that opportunity. But we're missing a UAC bypass when we were out in Vegas, and Matt's like, oh, I have a UAC bypass, I'll port it over. And indeed he did, and that's there. And then we had a student in the CYB 320 class that we listed under the acknowledgements, who I asked the students, I'm like, all right, raise your hand I asked lots of questions of the class, and it was like, raise your hand if you know how you would blind an EDR without having to tamper with it. And I was looking for what we did, which was to create a host file to sinkhole the traffic. Well, they raised their hand, they're like, why don't you create a Windows firewall rule? which was not the answer I was looking for. I'm like, that's great. Why don't you make it? And they did. So that's now part of the framework. So AutoPwnKey includes an agent for covert delivery and initial access. Scenarios for this, we have a demo that we'll touch on later about like ways you could deliver this. But a common one would be you find a flaw or vulnerability that lets you drop and run a file. This would be a very useful file in a red teaming engagement for you to drop. It would take the place of any other way you would introduce a beacon, such as a Cobalt Strike beacon or some other beacon. It includes a server to manage multiple agents with an upgraded GUI. Again, we really wanted to make this useful to red teamers because we really think that's what's going to drive the change, right? For me, when something shows up in a bunch of pen test reports, I open tickets. If that happens, I think that it's going to drive us towards some different ways of doing this that we'll talk about at the end. There's a lot of new features for defense evasion, including the DLL unhooking that Ezra was talking about, as well as just the overall detectability of the framework has been quite evasive. We've had leading EDR products that pretty much the whole thing works on without any detection end to end, everywhere from the beacon to Keylogger to remote execution of code, or lots of features. So
Cool. So
yeah, that's right.
test. Okay. Oh wow, it sounds different. Yeah. So what I'm going to do is go through a few of the modules we have and just give an overall overview of how this framework will actually be intended for use. I might have to reconnect to my hotspot for some of them. So this is what the GUI actually looks like. So as you mentioned, we have a server and an agent, or you could also call it a beacon, use whatever word you want. And the way that this works is the agent is a AutoHotkey script that we built to connect to a remote IP, and it listens for commands from the server on a port that's open on it. So the hosts I have over here, this one will be victim 1, this will be victim 2. For this one, the script is already running. So you can see over here we have one agent online, and that's this host right here. And as Mike was saying, we have about 20 modules implemented that have most of the stuff you'd really need to test these sort of capabilities. So going through a smaller version of like cyber kill chain, we have discovery, evasion, escalation, persistence, lateral movement, and impact. So just to demonstrate like basic functionality, you can just submit commands to it. So we'll do a simple who am I and queue that up. The agent will listen in every, I think it's by default every 15 seconds. You can see the output down here. That is the user I'm logged in on this machine here. And again, like he said, the way we built this, we want people to use it. So anything on here that you don't understand, we have all of the documentation built into the GUI. So if you don't know what the command does for any of these modules, you can just open it up and this will tell you all the parameters, how it's used, how it's implemented. And of course, all the code's on GitHub too, if you really want to look deep into it. So besides the basic commands, we also have some other things. If you guys have read recently about Winget being used for PowerShell execution, this was something that came out in December. One of the key things about AutoHotkey and like frameworks like this is it's really extensible. So as soon as any new technique comes out, it literally takes 30 to 40 minutes to implement it within this agent and this server immediately. So this is a simple PowerShell script just showing the functionality with Winget. So I'll just go ahead and run it. You should see an actual command terminal open up on the other host. There it is. It won't actually show any content, and you can make them hidden, but for demonstration purposes, it's better to show it. So you can see this script, like it says up here, it's getting the execution policy and the host information, and it's just returning that. Beyond that, we have a bunch of other modules in discovery, specifically for Active Directory. So we have some scripts to identify domain controllers, domain trusts, and a few other things. I'll show these later, because the first victim isn't on a domain. Beyond that, going into evasion, like Mike was saying, we have the ability to unhook ntdll with this agent. So What this will do is, like I touched on earlier, for the agent's process, it'll copy a clean ntdll from the disk and then essentially inject that into its own process, overriding any EDR hooks that are present in it. And I want to specifically mention, this is a really old technique. This isn't anything new, but it's never been used in AutoHotkey specifically. So in our testing with multiple different vendors, this was completely undetected for most of them. So after we were able to do that, for ntdll specifically, that lets you read and write files. Something else you can do with direct calls to ntdll is read files, encrypt them, and then write them. And I'll show that too. So going beyond that into privilege escalation, like Mike mentioned, we had a lot of help from Matt Handy. I don't know if he still works for NASA, but he was a security leader at NASA previously. I think he still is. He helped us out with this script. So this uses CMSTP. I don't actually know what it stands for. It's configure or connection manager, maybe connection manager profile, something like that. It configures a connection profile for the system, and the way that it's set up is just really poorly done by Windows. So really quick, I'm going to go in here and just open a command prompt to show the current privileges of this account. So this account is in the local administrators group, but as you can see, this specific command prompt is not running as admin by default. So I'm going to go over here, click Q, and you can see that pops up. And then we got system 32, do it again. And we have everything. So in the context of an actual engagement, this isn't going to help you get an account that has admin credentials, but from the agent or from the server, you can completely bypass having a UAC prompt. So typically, if you're launching command prompt as admin, you'd have to click through it, but you can do this completely remotely and then send other commands to it. Going beyond that, we can go to persistence. So we have a few just simple persistence modules here as well. So depending on the privileges of the user you're running on, you can add new admin accounts. You can add the script to the current run or the current version /run registry. So by default, we can just run this. And what this will do, you can see right there, it says registry created successfully. Now the agent that we have on this host over here is going to start up every time this user logs in. And for a general user, they'd never know. For an enterprise environment, they might know, but the EDR did not detect this. This specific script was not detected for any of the EDRs we tested, which is scary. We have similar things, so you can also just add scheduled tasks for whatever application execution you want. By default, this also just launches the agent itself in 24 hours, but you can add anything in here. So we've set it up that any sort of command line you want to launch on a delay, you can do it through here. Going to lateral movement, we also have a few fun ones. So this one will install a MSI on the victim host silently. So if you have a file or a payload that you've put into an MSI, you can do it through here and just change the URL for it. And then the RDP connection, I need to connect to my hotspot so that we actually have internet for this.
So I think this is where I do stand-up comedy and drop more things while Ezra sets up the demo. So he said poorly implemented by Microsoft when we were talking about that UAC bypass. I mean, said nobody ever, right? It's you got the hotspot. Oh, okay. What do you call a dog with no arms and no legs? Yeah, you don't. It doesn't matter. Don't call him. Like, go pick him up. Like, he's not coming anyway. Let's see. I really should have read my dad joke book this morning instead of trying to cram in a few new features to this at the last minute. That's the number one thing. If you do demos at cons, have lots of stall tactics, jokes, and things that you can insert when things break. And I think we're ready.
Cool. So essentially what this script is doing, and this is my favorite one just because you actually get to see what's happening. What it's going to do is on the first victim, it's going to initiate an RDP connection to any host that you specify within those parameters. It's going to connect to that host, and then it's going to open a command prompt, download the agent from GitHub, and then launch it after installing AutoHotkey itself. So there's a lot of applicability for that depending on how you're using this. I just need to make sure. It doesn't look like this says it has a connection, but I definitely am connected. Well, we'll see if this runs. If not, it'll be funny.
We have to have at least a few things that don't work here, so.
Oh, there you go. So as you can see, one of the main things about this too is that it automatically accepts the like, this is an insecure, or you haven't connected to the server before prompt, which is really annoying because those are like halfway between a UAC prompt where you can't actually address them with AutoHotkey. So for anyone familiar, with AutoHotkey, you can like activate a specific window based off its title, but those prompts don't allow you to do that. So I do think it doesn't have, it doesn't have internet because it didn't actually send the command, which is unfortunate. But I think you kind of get the idea.
It didn't work because my jokes weren't good enough.
Yeah, it should have got hooked up to the Wi-Fi, I guess, but that's okay. Beyond that, I also wanted to show, so like I was saying, we can also just encrypt files with this. So if I go on this victim host, go to documents, and we will do, I guess we could do the entire documents folder. That'll be fun. I'm just going to create a new file really quick. I forgot I reverted to my snapshot. Edit this and put content. All right, so I'm just going to grab this folder path, go over here, paste it in, and we'll just do a simple password of password because we're security professionals. Queue that up. And you can see down here it says encryption completed. If we go over here, we'll need to refresh it. It doesn't look like that actually worked. You know what? That's probably because of the space. 1 second. Like I said, it's not a fun demo unless you're also showing how to troubleshoot. The other thing, I'll mention this too. Me and Mike have mentioned this at every talk we've done so far. We're not developers. We don't actually have development experience specifically. So while I am very proud of how far we've come with the framework, there are a lot of things that aren't fully implemented. So like file paths, you got to be real specific about. Otherwise, like you just saw, it's not going to recognize since there's a space in it. Okay, let's try this again.
Special thanks to Christian for developing the first iteration of this module. We noticed it worked a little too good, so we've actually added safety features to it this time to make it like a little more specific. And a little more convenient to test with because you know the first version of it worked a little too well.
Yeah, that still didn't work. I'm not really sure. I did test that yesterday, so you'll just have to trust me.
And if it breaks for you, do a pull request and.
Yeah, that's.
Oh yes.
Yes, it is.
Thank you, Andy.
Yes, it is. I forgot. Okay, wrong host. Okay, there we go. Let me try this. Yeah, so the reason why 1 RDP, 2, since it's a different user, the file path is different. I was wondering, I was like, I swear this worked yesterday. Oh yeah, there you go. See encrypted file. And so for all of you, specifically for those thinking about EDR, I tested this with 1 EDR in a massive volume. So I know, Andy specifically, thank you for mentioning this previously. When it comes to encrypting files, it's normal to encrypt files on a system. That makes sense. What's not normal is encrypting 20 gigabytes worth of files on a system. But this specific module was not detected no matter what file size I used. So I literally like duplicated the same gigabyte file 20 times in a directory, no detection. And so just to show a few other things with the agent, once we actually have that encrypted, I can also just copy the file path, go over to file transfer, paste that in. I have to get rid of the quotes because once again, I did not strip quotes when I coded this module, and request it. And then down here, you can see the actual logs for it. Refresh this. And so we have that over here as well. So that's really tedious for a single file, but it'd take about 30 lines of code for this to encrypt an entire drive or directory, copy each file, send it back to the server, and then delete them. So it really wouldn't be that difficult. For testing purposes, we also have a decryption function in case anyone ever uses this for an actual system. So I just put in the same path, same password, and queue it. And I will mention, if you lose the password for this, your files are gone. Sorry, so be careful. Yeah, so I will. It's stored locally in the logs for the manager, like the file you use, but just want to throw that out there for anyone that tests it, and you can see it's unencrypted. Cool. So besides that, we can also show our keylogger. This one, there isn't much documentation on, but it's pretty simple. It logs keys. So if we just press start and wait for the agent to receive that, you can see down there, and just start pressing buttons. Yeah, it runs into errors sometimes if you press too many too fast, but you can still see that's what I just typed on the keyboard is CactusCon. And again, I'll note this module we tested with multiple vendors, and it wasn't caught. And now that you've seen everything that this can do and have the context of what we're actually using it for, and the fact that EDRs are not catching this sometimes depending on the vendor, the communication for this is all plain text. All of it. Like, so what you're seeing down here, this received keylogger output, that's plain text sent to this server from the agent. So I just thought I'd mention that. We specifically didn't implement any sort of obfuscation for the C2 communications because it still worked in plain text. So why would we make it encrypted? Was there anything specific you can think of you want to show?
Do you want me to do the weaponized doc? Or
Yeah.
is there more stuff you want to show first?
I can set up, while you're doing that, I can set up the agent on the domain so that you can show the other.
Like swap.
Yeah.
You'll see us sitting on the floor with the laptop sporadically throughout the demo today, debugging and playing with things.
No problem.
Yeah, I can't comment on that because this is recorded. Yeah, so this demo environment, actually I need a dongle for this one. Yeah, no, so actually I'll just cut ahead and steal a slide for later. Feel free to, you can set up. But so what we noticed, we tested on a lot, but not all. Like basically I test on usually 5 or 6 when we think we're close to done. There were random things that were caught by some, but generally you could do a complete compromise path on each. But a friend of mine who I'll keep anonymous for obvious reasons provided with proper written authorization a government laptop running 2 different products. And last night about 12:30, we had some fun doing some testing. And what's interesting, we're going to do a demo here of like a weaponized document delivery. And to their credit, it was a tremendous success story because we tested it end to end. Everything worked as intended, except the weaponized document was blocked like multiple ways. Their controls and their host hardening worked really, really well at stopping that. And I made a mistake with the weaponized document that makes it a little too easy to detect for like if you're really running a red team engagement, and we'll talk when I demo it what that mistake was. But then we ran through the whole demo. This laptop was running 2 EDRs, and one of them detected nothing all the way through. The other one, we went to bed and shifted to like tweaking slides, and then I woke up to a phone call and a text message this morning, and the laptop contained. So to their credit, they did a phenomenal job. The weaponized document triggered an alert that caused their team to do hunting, that caused them to manually see all the other commands. And then their process worked great. They actually contained the laptop by the time I woke up this morning and called me first thing in the morning, like, hey, we caught you. So it is good, right there. This definitely isn't a hopeless scenario, and we'll get to more of that in defensive recommendations. And if you're ready, I will shift to That seems like it should be a drinking game for CactusCon. Digging for dongles.
So the only other thing I wanted to show, that first victim wasn't hooked up to domain, so it wouldn't have given anything. But we also have a few domain enumeration scripts. So specifically, we just have listing the domain controllers, the trusts, admins, and then Mike, did you want to go over the unconstrained delegation piece as well?
Yeah, so thanks to Jim, who's here anonymously, I won't point him out. His GitHub's in the acknowledgement section. We were like tinkering with in a couple prod environments with AD tools, and we're like, what should we do? Like, what should we test? And Jim suggested checking for unconstrained delegation of basically the ability to impersonate with impunity would be a simple way of putting it. And we managed to cobble something together last minute, and then it sort of worked.
Yeah. And so I mentioned too, this is another thing, this was one of the things that we tested in a prod environment yesterday, and it did successfully find results for that without being blocked. So as Mike mentioned, a lot of, after, I don't know how many hours it was after we tested that it was actually detected, but when we ran through all of that, none of it was blocked immediately. It was after the fact that it generated some sort of telemetry that they caught on to.
It's my theory on that if we wouldn't have messed around for 20 minutes with trying to get the weaponized document to work, because we thought it would look cool, if it weren't for that, I don't think it would have been detected, but that definitely set off some flags. And then once that triggered their processes, they absolutely rocked it.
Yeah. And so just a couple other things I'll show too for fun. On the second host, so that's the domain connected one, it's running as admin. So some of the things that you can also do, if you do have administrative privileges, you can block outbound traffic to any sort of agent or sensor. This will automatically recursively search through program files for any of the target file names you mention. So you can block traffic for anything. And again, this wasn't detected by some of the sensors we tried it on to block their own traffic. So the use case for this obviously is before you do anything else, you can just prevent the sensor from reaching out to the cloud. So even if it does detect the activity and block it, they're not going to know yet. They won't know until they see that that host has been offline for however many days and submit a ticket to see what's going on. Same thing for the host file. This is a little different, but same idea. So for the host file, you can put in specific URLs and it'll just redirect those to localhost. So for example, actually, I don't know if I have internet. Let's check that first. Let's try everyone's favorite site. Okay, so I do have internet on this host. Good. And then we'll just go in here and we will block bing.com, queue it, and it'll take a couple seconds. All right, so I added the entries and we'll refresh it. And it still worked. Okay, we'll try a different site because that's probably cached now that I haven't visited too. Let's try LinkedIn. Okay, then go over here. Yeah, and it should just keep loading. Yeah, because it's going to localhost. So obviously, it doesn't really make sense to block LinkedIn in an engagement, but if you know the EDR vendor your target is using, and you Google the documentation for where their cloud upload is, you just block those URLs. And it's at this moment, probably not going to notice. Yeah, I think that's all the demo specific stuff, unless there's anything else you can think of. Is that ready?
Yeah, it's
okay.
Ready. I think it'll work now. I came to the con with 4 different laptops, so I keep getting mixed up which ones are which and which ones have which ports. You do not want to volunteer to carry my backpack around today. So what this is, one of the things, is it going? Let's try a different port. Yeah, oh, there we go. Okay, so what?
It's not on the screen though.
Oh, it's not. It's loading. Okay.
Taking its time.
Strangely, it's missing a bunch of screens. There we go. All right. Now we're talking. Now we need VMware. Oop. And it looks like VMware completely crashed when I plugged it in. So I'll just talk about this. What we did, and who knows, it might come, well, look at that. All right, it's magic. So I'm not even going to try to get the Kali instance back up. But basically what we thought about is to make this useful to pen testers, it would be really useful to be able to email it. And so we played with a few things, right? Like you can do a batch script to drop AutoHotkey 64 and a batch script to run as. You can do a lot of different things, but we wanted something kind of more realistic and closer to what adversaries are really doing. So what we have is a tax rate calculator here, which of course we didn't put this in this form on GitHub. We actually sort of obfuscated what's on GitHub as instructions that a pen tester will have no problem following, but hopefully isn't turning something out there too easy to abuse. And so what it is, and I actually was debugging something, those tabs are usually hidden, but we'll look at them unhidden to see what they are. We have AutoHotkey written to using encode insert util to encode AutoHotkey's executable as a certificate on one tab. Then on another tab, and this is the mistake I mentioned that got it flagged, we have the particular, like the AutoHotkey beacon on another tab. Those two tabs are hidden, and what it's doing is when you open it, of course, I would need to save as a new version because I was playing with this a minute ago. But what it's doing is it's writing, first it's actually doing a base 60, it's opening a macro. You know, we've got like a little bit of social engineering there, click active content. It's doing a VBA macro to decode AutoHotkey 64.exe and write it to the current working directory. Then it is taking the AutoHotkey file, writing that to the current working directory, and then it's running the AutoHotkey script with the AutoHotkey 64.exe executable. So the net effect is, which again, we don't have the listener up, but if we expand this and it worked, we should have.
It'll auto close since the listener's not up.
Oh, okay. So we'll just do it. We'll just open it again. No, I do not want to change save settings. Here we go. So when we open this, and let's get Task Manager handy, since that'll be the only way to show it's working. You'll see a flash of AutoHotkey, and the reason it wasn't showing, the parent process is actually Excel, unless you close the spreadsheet. And then now it's erroring, of course, because the listener's not there. But the whole idea was getting AutoHotkey 64.exe delivered in the same package as a way to unpack it and in the same package as the script. The next iteration of this that won't be now that ran just fine on multiple EDRs with no detection. Email security gateways did a good job of sandboxing it and catching what it did. But I suspect that with the small tweak of putting the AutoHotkey file also as cert util encoded first so that it decodes, I suspect it will probably work. And there's our error message, registration failed because there's no listener. And with that, I know we've got about 5 minutes left. We'll go back to the last few slides here.
Cool. So, just like a general recap for this. Oh, this is your slide.
Oh, it's all good. Keep going. You got it.
So we won't be specific, but we tested a good amount of EDR vendors, enough to be representative of EDR as a whole, to us at least. And one or more of them failed to catch running a payload that establishes a connection in plain text, running various discovery lateral movement oriented scripts, so all the ones you saw, defense evasion through the ntdll unhooking, which again, that's an old technique, and also just impacting a ton of files. And so beyond that, a scary but smaller number of EDR vendors didn't detect anything we tried. That includes the macro. So like, it's just a little scary. And that last point we already went over. That was the test we just did last night.
Yeah, so there's a few aspects for this. How would you use this in a red team engagement? Well, one, we'll clean up the weaponized document further, update the GitHub with newer instructions, and also maybe some comments on how well it works or doesn't work. We don't entirely know. But we were playing with this a lot via presented apps and escape to host. So one of the use cases that we're going to give a future talk on, and we'll probably write up a blog post soon about too, is containerized VDI style application delivery programs are really, really bad at providing opportunities to run files or code on the servers they're running at. So like a lot of the end-to-end production testing we did on this from a red teaming perspective was find an escape to host flaw that let us run a file and then run this from there. So on the escape to host side, it's definitely if you're running an application delivery platform of any kind, go actually test it. Go see like, hey, if I open up this application, am I on the file system of the host or server? If I print, can I use the print features to enumerate the domain? We'll, again, more to follow on this at a future con, but escape to host combined with this would be a very, very real avenue to have a lot of successful results in pen testing.
Cool. So on the actual defensive side of this, we'll spend the last few minutes just going over, well, what do you actually do about this? For AutoHotkeys specifically, because of the way that they're compiled, they import a ton of DLLs when the process is started. So in our own environment specifically, launching even just a benign AutoHotkey script was consistently within the 97th percentile of all processes in the enterprise in terms of the quantity of DLL imports. So if you have a sensor or whatever your EDR is that records the amount of DLLs or process imports, that's a really easy way to pick out things like this. And I should give the caveat that's excluding system files, so like actual Windows binaries, not living off the LAN binaries, but they're actual like login processes. They will AutoHotkey will be consistently at the top of the list. And beyond that, I didn't really go into it too much, but in the GUI, each module has documentation that also shows the artifacts it would leave. So the event IDs for the ones where that's relevant, or the logs where that's relevant, it'll show you what you need to look for if you want to go after our framework specifically, which I recommend you do.
Yeah, and so like one thing, obviously document and baseline if AutoHotkey, AutoIT, some of these tools are used in your environment, but just block them, right? Like if you just write a custom IOA and put that in your EDR, it may not detect all this stuff, but you have the ability to use GPO or the tools you have to just block AutoHotkey, and this problem is instantly solved. So if you're curious, go back, load all this, test it, and open tickets with your vendor, because that'll help fix it globally. But if you're just like, I don't want to do all that, just block AutoHotkey and block AutoIT with custom IOAs, and you are good. We definitely want to continue to push on our antivirus and EDR vendors to keep them honest and to keep things progressing in the right direction. And if people are using AutoHotkey or AutoIT, like redirect them to safer, better alternatives would be my 2 cents there. So certificate blocking, custom IOAs, host firewalling in general, right? Like a lot of these things require to work in the real world an arbitrary connection out to a C2. If you've done your host firewalling, especially in a data center space and or micro segmentation well enough, you're going to be in really great shape there. And then I think we already talked about the over-reliance, so I'll move over this over time. How you can contribute, test it, open tickets with vendors, but also red teamers, use it, fork the project, contribute, use it freely. Anything to add on that? No. And then lastly, just thank you to everybody in the room and not in the room who's contributed, Cameron, Jim, Christian, Cyrus. A lot of people have contributed a lot of effort to this, so thank you. And we'll open it up for questions if we have time for questions.
When you were setting up the
No, it runs completely user side. So that's a bit on the defensive side of this. If you, in your environment, if your users can download an executable, it can run. So it doesn't require an install at all. So that's why it's really important on, how much time do we have?
Yeah, we have 5, so we should talk about app control.
Yeah, so that's why, like we were kind of getting on, app control specifically is really the only overall defense for this, because you need to make sure you're aware of, well, one, can your users run anything they find on the internet? And if you're like, hey, well, we blocked the download of executables and zips, that doesn't matter. They can download a docx and it can be put in that way. And it still doesn't require any sort of privileges beyond, can they write to appdata/local and launch a executable? So if they can install Chrome, they can install an AutoIT agent. Yes, correct. It runs completely in the user context. Does that answer their question?
Mike, Ezra, and all the students, and I saw earlier. I'm curious what kind of responses you're getting for
I think they're gonna send in the team. The EDR vendors are sending in the team with like the black hoods are coming out, going dark. No, so we've had one vendor in particular that was really responsive and all over it and reached out to us. And then we had another very popular vendor that did improve over the last 6 months, but did not do basically there's been open tickets since DEF CON on some of this stuff.
And
For the vendors that did catch it, what were the detection methods?
so it depends. So I'll mention, well, right now for this AutoPwnKey, no one has created anything specific for it. But for our last framework, Bypass It, which same idea based off of AutoIT, it's mostly just based off of the actual executable. So like the AutoHotkey interpreter is what they're catching. And I've noticed that for the logs for it, it doesn't actually understand what most of the scripts we have are doing. It just knows they're probably bad. I will add, so our previous framework, Bypass It, as of, well, I tested it this morning, Windows Defender caught one of the scripts. So Defender's about 6 months behind our release. You can do the math to fill in the rest, you know.
Quick follow-up question. Is creating a copy of ntdll, or is that a common practice across other applications? That feels like it's a copy.
So that is one of the best detection methods for that. And that's what they do for any other binary that you'd create. So like if you just created a C# binary and copied it ntdll from disk, that'd be detected immediately. It's only because it's AutoHotkey, because it's heuristically trusted, because that might be a normal thing for it to do. That is a really good detection method. So once that starts getting detected, what you can do from there, and this is what other programs are doing as well, is instead of copying it from disk, just analyzing the functions that have been imported, looking for different jump instructions, and just removing them. So you can accomplish the same thing without reading from disk. It's just harder to implement. And we didn't bother because the base version worked. And I'll add too, the ntdll unhooking, that's something we implemented because it's what is being done in the wild with AutoIT. So Luma Stealer, if you've ever heard of them, they're currently using that within AutoIT. That's one of their drop methods, is doing it that way. So that's where we got that idea from and realized it still worked, because that has been around quite a while. Any other questions? Nope, no comment. Talk to me later.
All right, thank you all. I know we're out of time, but